Alright, hi everyone, my name is Kyle.
My name's Peter.
I'm Alexa.
And we're the ISIS group, and we focused on the impact of Syria's impact on nightlights and agriculture. The Syrian civil war started in 2011, and ISIS started to come in the news and take over large chunks of territory in 2013. So here's Syria, here's Iraq. And for our study areas, we focused on Raya, or Tadmur, which is a small oasis town, and it's a UNESCO World Heritage Site. Raqqa, which is the capital city of ISIS that has been heavily bombed first by ISIS and then by rebel groups, and then the US and Russia and France and pretty much everyone. And then Lake Assad, which is the largest lake. This was made by a dam, and there's lots of agriculture around that area. So those are our three sites that we focused on. Another point, it's very dangerous to go to Syria and Iraq right now, so that's why it's really important to focus on remote sensing, because we can't get people in there to have direct samples.
Right, and the two main objectives of our study was to find the effects of the Syrian civil war and ISIS on agriculture, which we achieved through NDVI change detection, and the second part was to see the effect of the change in nightlights. So for the nightlights, we downloaded Defense Meteorological Satellite Program data, or DMSP, and the VIIRS data, and we took DMSP images from 2010, 2011, 2012, and 2013 to capture before and after the Syrian civil war. And then for VIIRS, we got more recent data of 2014 and 2015, which would capture when ISIS started their offensives. And we brought these into NV and subsetted using vector shapefiles from the United Nations to outline the Syrian boundaries and the boundaries of the sub-districts of Tadmur, Al-Raqqa, and then Aleppo, which is the most populated city in Syria. And then we did a change detection. And then we brought it all into our map to change the color schemes.
And then for the Landsat analysis data, we used Landsat 5 and Landsat 8 from pre-ISIS occupation in 2011 and 2012, as well as recent data from 2015 to look at the changes in NDVI and the change detection in several areas regarding to agriculture.
And here's some of the nightlight results. This is for all of Syria. Here's a comparison of 2010 to 2015. You can just even see visually at this point that there has been quite a lot of loss in nightlights. And then here's a brightness value map that we made in ArcMap. So the one on the left is nightlights in 2010, and the one on the right is 2013, and it uses the 0 to 63 digital number scale for intensity, with 63 being the most intense. So you can see there's been quite a large loss, especially in Aleppo and in the southwest corner here, which is Damascus, which is the Syrian capital, and then also in Al-Raqqa, which is where the ISIS headquarters are currently. And then this is using the VIIRS data, which is the 2014 to 2015 change. Red is a negative change, and green is a positive change in nightlights. Overall, there was a decrease in nightlights, particularly in the urban areas again.
This is just a visible of Tadmur using bands 3, 2, 1.
And then we took a look at Assad, which is right here, and the agriculture that surrounds it, which is the main source of food for Syria. In the infrared, that really emphasizes the healthy crop life. And we see that the density in the crop fields between 2011 and 2015 really diminished. And then here's the change detection for it. The red is loss, green is gain. Over 70% of the areas here notice some sort of significant NDVI loss. And then this is the area around Al-Raqqa, which is the city in here, and the Euphrates, which is the river that runs through it. This area saw an even greater decrease in NDVI, and the agriculture change around it has diminished severely.
And For our results from 2010 to 2013 on the DMSP data, Syria overall experienced a 43.57% decrease in nightlight intensity, and it's difficult to determine exactly what the cause of this is. A lot of it's probably related to the Syrian civil war. This could be due to a combination of factors, including refugees leaving, so leaving a reduced need to have urban lights, or just a reduced impact on urban energy use. And it's also been hypothesized in another related paper that ISIS has not had access to the Syrian power grid.
And then for our agriculture analysis, there's obviously been a large decrease in the vegetation. We're unable to say why. It could be due to the drought, could be due to the war, could be due to a combination of fleeing migrants and people not being able to safely practice agriculture in the area, as well as the very, very serious drought in the region that is very devastating towards agriculture.
Yeah, and we would look to expand this research by increasing the dates that we looked at so that we could hopefully get more specific causation, whether maybe a specific ISIS offensive directly caused a loss in vegetation or something like that. So that would be our next steps. Here's just a little movement so you can see the decrease in nightlights from 2010 to 2013. And then here's a graph of the loss in nightlight values. You can see that all of our study areas experienced a significant decrease. The y-axis is the 0 through 63 scale. So yes, all of them experienced a large decrease, and here's the percent decrease. It's very significant. Aleppo had a 75% decrease in their nightlights from 2010 to 2013.